Okay, just a quick review of yesterday. Mid-segment, how's it formed? In a triangle, mid-segment. How is a mid-segment formed in a triangle? We have a 25. How about a 4? How's a mid-segment formed?
By connecting the midpoints to
Any two sides. Any two sides connect the midpoints of a mid-segment. Or the two, one fact about a mid-segment in a triangle. 28, nope. 26, nope. How about 14? How about 3? Parallel to the third side. What do I mean by the third side? That's my next question. We're starting this vocabulary. Third side, what's that mean to you? 14, what's that mean? 1. Third side to a mid-segment is the side that is not connected to the mid-segment. Perfect. Parallel to the third side, and what about its length? 16, what about its length? Half the length of the third side. So I think we ended class yesterday by saying that they are obviously not equal, but you could adjust it by multiplying 4x minus 5 times 2, or if you didn't like that, you can multiply the 6x minus 4 by a half. So you do your distribution. Here's where we did not get to. What was your value of x yesterday? 13 value of x? I think we just got to redo everything here. 15. Not here? Okay, what do we get for x? 3. I'm going to really push this semester. Have some discipline. Just because you find the variable doesn't mean you found the final answer, or in this case, answers. So plug it in for PQ, plug it in for XZ. 3, what do we end up with for PQ?
7.
And for XZ?
14.
Okay, and that makes sense. One is double the other, one is half of the other. Anything you want to ask there? Okay, I really don't find it efficient for me to just say, go start the homework for mid-segments. We need to review, all right? Because the first half of this unit was done 3 weeks ago, so we need to start reviewing, getting ready for Friday. And that's exactly what we're going to do most of the time today. So the first one, you go to the back of your packet, find number 6, please. In the back of your packet, the review section, number 6. I'll give you a minute, set it up. If you want to write down givens, let's write it down. If you want to take a nap, get out today. All right. First thing we got to figure out, how's this proof going to end? All right, how's this proof going to end? Look at the proof statement. Just by the proof statement alone, how's this proof going to end? With what? We had a theorem before the midterm. We started reviewing for the midterm that said product of the means equals product of the extremes. That's how this is going to end, not with CSSTP. That's why I'm reviewing this right now. It's going to end with means and equal to extremes, but that can't happen unless I know what about the triangles? Similar. And if you look at the diagram, I can at least see 3 triangles in that diagram. And we're just not going to pick and pray, pick 2 of them and pray that those are the 2 we need. What in our proof can help find the 2 triangles we need? The proof statement. Name the first segment in the proof statement. AB. Take a look, everyone. AB. I think we can all be, most of us could be in agreement right now that AB is a full side and only one triangle in that diagram. Name it. ABC. So we at least have 1 out of the 2 triangles we need. We keep reading the proof statement. The next segment that's listed is DE. Same thing. I think we can almost all agree. DE is a full side and only one triangle. Name it. CD. All right, we have the 2 triangles now. Review. 3 methods of proving triangles similar. 3 methods. Angle, angle. Side, angle, side. Similarity. And side, side, side. Similarity. Only one is used in a proof. Angle, angle. I can't use, how can I use side, side, side? I don't know either, unless I know the side lengths, which will never given to you. There's only one way to do it in a proof, and that's angle, angle. So here you go. You're up now. Give me a pair of angles. 18, give me a pair of angles somewhere. Angle D congruent to angle B. Gonna need somebody else. Let me know why that's true. D and B are congruent because 5. They're opposite angles in a parallelogram, and since we know our properties, we know they're congruent. D, B congruent. All right, I still need one more pair before they're similar. 23, any other angles? Here you go, 10, any other angles? Okay, these 2 right here, everybody. What type of angles are they? Alternate interior, but they are not congruent unless I have what? They are not congruent unless 10, what do I need? Okay, now here's the part I still worry about to this day, 20 weeks into the year, that you know which 2 lines I need parallel. What lines form these 2 angles that were just given to us? What 2 lines form these 2 angles right now? Here we go. Let's go. 4, what 2 lines? Okay, there we go. So I need BC parallel to FD. Reason? Here you go. We got a 24? Okay, how about a 12? Now you can say those angles are equal. You don't need to tell me the whole parts thing. That's fine. If you put it in, it's still acceptable. Not needed though. So angle BCE congruent to angle CED. Why? I'm going to ask a lot here. 26, yeah. 15, why? Not here. 15 here? Sorry. Why, Ansley? Why is that true? Alternate interior angles congruent. Now the triangles are similar. Give me a good statement. Proper statement where everything matches up. 8, proper statement. Triangle.
Triangle ABC is similar to triangle CDE.
CDE. Again, angle, angle. Here's where I get more nervous. You can't go right to means and extremes just because the triangles are similar. You need a what established to go to means and extremes? A ratio established. You need a proportion. You can't cross hey, anybody cross multiplying on that statement? No, me neither. The only thing I'm going to cross multiply with is a darn proportion. That's got to be set up in such a way where I am going to multiply A, B, and DE. So let's see if you can do a correct proportion so you're multiplying those two, because they have to be put in certain spots. What's the proportion have to be? So I can multiply those two. Do I have 19 here? Okay, quick check. AB times DE, perfect. Diagonal from each other, BC times CD. This is not means and extremes, though. What tells me the ratios are equal? Corresponding sides in similar triangles are proportional. Now can I cross multiply? Once I have a proportion established, you're darn right I can. And this is the final step. AB times DE equals BC times CD. Product of the means equals product of the extremes. Please make sure you are aware of the order everything has to go and the correct reason for it. You cannot skip from angle to means and extremes. The reason for this one is not means and extremes. 2 proofs on Friday's test, 2 proofs. Could it be CSSTP? Maybe. Could it be means and extremes? Maybe. Any questions right there before we keep reviewing? Number 3. Are they similar? If they are, write a statement and tell me why. One more time. Reason, 3 reasons. Angle. Side, angle, side, similarity, and all right, side. There you go. Those are your 3 ways we have. Please look at A. What is the only option it could possibly be? Side, angle, side. I don't know where side could come from because we have no idea the side lengths of the missing ones. And I don't know where angle could come from because we only have 1 pair. 1 pair doesn't magically make another pair congruent. So we need to figure out, are the sides in the same ratio or not? I'll start 3. The side of 3 matches up with what other side in the other triangle? 4, what's it match up with? 7.5. Is that the same ratio as the 4 matching up with the 10? You either can find the decimal equivalent in your calculator or cross multiply. And what do you notice? Are they the same? 30 equals 30 when I cross multiply. Somebody give me a statement now that says they're similar. Here you go, 10, give me a statement. Triangle. Good. And what method are the 2 triangles similar to? Side, angle, side. And yes, I am going to be taking off on Friday. That's for congruent triangles. We need the tilde there, please. Side, angle, side with the tilde. All right, let's look at B. What could it only possibly be? It could only possibly be side, angle, side. I don't know where you're getting another pair of angles from or the third side, pair of sides. So we're going to test here. Let's see. The 5 will match up with the what? Here we go. Do we have 24? Nope. 24. Let's keep going. 1. What's the 5 going to match up with? 8. Smaller side. And the 6 matches up with the 9. Are those in the same ratio? 5 over 8, the same as 6 over 9? Nope, because I don't think 45 when I cross multiply equals 48 when I cross multiply. All right, so these are just plain old not similar. Questions there? Just a review of ways to prove triangles similar. And one more, and that's going to be some algebra now. 8. We hit up a proof. We hit up ways to prove them similar. Now let's find a side using some algebra. Got parallel sides, which I needed. I got AB is x, AC is 3. All right, let's talk. I showed you this theorem called the side splitter theorem, which could be applied here. Side over side equals side over side. That's fine. I prefer, though, if you guys want to use that, that's fine. I'm going to go whole sides here. All right, let's do whole sides only. So I'm going to start with side AB is x. Just name the side that corresponds with AB. Name the side that corresponds with AB. 13, name the side that corresponds with AB. Perfect. How about 24? Nope. 7, there we go. Name the side that corresponds with AB. AD, can you tell me the length of AD by combining those two sides? Everyone all right? X over 2x minus 2, how they correspond up here. All good? All right, let's go to the other side in the small triangle, which is 3. Side AC is going to correspond to which side? Here you go, 11. AE, can you combine like terms and tell me the length of AE? X minus 1. Any issues there before we get to the algebra part? So you have x and x minus 1 equal to 3 and 2x minus 2. Hopefully we can handle this distribution. X squared minus x on the left, and on the right, 6x minus 6. I'll give you a minute because one side's got to be equal to 0. Move everything over and let me know what you get. What's equal to 0? 11. Move everything over. What's equal to 0?
It is going to be x squared minus 7x.
If you're by yourself and you want to use quadratic formula, that's fine, but I cannot have you go into Algebra 2 next year just using quadratic formula. You need to have some ability to factor basic quadratic equations. All right, what am I looking for? Two numbers that multiply to what? 6. It's got to multiply to 6, but add to -7. There are two numbers that do that. And those two numbers, 22? No 20. -1 minus 6. Okay, So we end up with two answers. We have x equals positive 6, x equals positive 1. This is a great example because I can't say this enough. Just because both are positive doesn't mean we're good to go. Positive and negative means nothing about rejecting or keeping it. There's a diagram here. What is the problem with one of our answers? What is the problem with one of the answers we have? 21? X equals 1 plugged in for side BD gives me -1 for a side length, which cannot happen. So perfect example right now of, yes, -1 is positive, but when I plug it in, it gives me a negative side length. So that needs to be rejected. And the only answer I can fully accept is 6. We do not reject things if they're positive or negative. We reject them because when we plug them in, it gives us a negative or positive side length. Questions there? Nothing else? Okay, so you have options right now. One option is the mid-segment homework from the book. Second option are the 2 review problems on the back of your assignment sheet. A third option is not sleeping. A fourth option is not art class. All right, it is getting to one of the first 2 options. Here we go.